All right, you have survived 2 very long videos, or maybe you just didn't watch them and you're jumping because you love applications, okay? We're only going to do one application. They're all very similar. We have some model. In this case, we have a population model over here, okay? So notice, let's tie things into the very beginning of the chapter, exponential functions. A, e to the r, t. A, sometimes we use the word p, the letter P. This is our initial population. Okay. The initial population is 23,500 people. Kind of like Rock Springs. Okay. Very close. E to the R. Our R is negative here. R is negative means exponential decay. Okay. And a lot of places in Wyoming, I don't know if Rock Springs is one of them, but a lot of places in Wyoming are losing population. So that corresponds with the negative people. People are moving out. Negative people, no. Negative rate. Okay. So anyway, we're wanting to know when the population is 20,000. So there's 2 things to look at when you look at a problem like this. It's asking when. When, right? That's a time. So the time is what we want to find. And we know the population is 20,000, right? This is the pop. So we want to find the time when the population is 20,000. So P is equal to 20,000 here. So P is 20,000. Replace the P with 20,000. That's going to equal 23,500. E to the negative 0.01. And I don't know what time it's going to be. We need to find it. All right. So we have to solve this equation. And we're going to be doing a lot more of these next week. I say next week, but if you're taking Thanksgiving break, which for you will be next week, for me, it's way in the future, then it'll be in a couple weeks. All right. Time is hard. So we need to get the exponential by itself. Divide both sides by that 23,500. So I'll have 20,000 divided by 23,500 equals e to the negative 0.01t. Isolated the exponential. Now we can undo it. Let's take the natural log of both sides. Left-hand side, let's keep an exact answer for now, but we can simplify it a little bit. It reduces to more than this, but very quickly we can cancel out the zeros. It's 200 over 235. But again, it reduces even more than that. They're both divisible by 5. Is equal to the natural log of the right-hand side, which just cancels, and we're left with that exponent, negative 0.01t. All right. All that's left is dividing both sides by negative 0.01. Negative 0.01 over here. Negative 0.01 here. And you're going to get that t. And normally I want an exact answer, right? But for applications, we always assume that you want to round at the very end, right? If I ask you, when is the population going to be 20,000? And you said, well, in about the natural log of 200 divided by 235 divided by negative 0.01 years. Okay, let's find an approximation. Okay, so we got the natural log of 200 divided by 235 divided by negative 0.01. That's going to be about 16.1268148 ... It's irrational. That many years. And again, if I ask you, when's the population going to be 20,000, Joe? And you say, well, Jason, in about 16.1268148 years. No, that's crazy. Let's round to the nearest year. You could round to the nearest month, but that's a little bit more complicated. We'll say in about roughly 16 years. And that's how we do these problems. So just identify what you're looking for, plug in what you know, and you'll be good to go. All right. And that's the section. Hope you enjoyed watching the videos. Let me know if you have any questions. And good luck. Only one section left.